reciprocal function, k, or it really is the inverse that we just looked at, that k over x. And we're going to be graphing those. So if we look at these, place a check mark in the ones that are reciprocals, place an x in those that are not. So are 7 8 and 8 7 reciprocals? Yeah, they just flip up and in. Yep. So that one is, how about the next one? Yes or no? Do they flip? No, there's just a 2 added, so that would be an x. Do those two flip? Yeah, because technically there is a 1 under there, so that is a check mark. Perfect. Page 10 is where we're at. Then these statements, we just want to know yes or no. A reciprocal positive number is positive. Yeah, we don't switch the sign. So look here, we had a positive 7 8, didn't it stay positive? Yep, so that's going to be yes. The reciprocal of a negative number is positive. No, if it's negative, it's just going to switch. It's like if the negatives are 2/3, it's going to be a negative 3/2. Yep, so they have to stay. Correct. A negative number has no reciprocal. Can I have negative 2/3? Can I have a reciprocal of that? Yeah, you can. You just flip them. So that would be 3 over negative 2. Yep, so that's going to be a yes. The reciprocal of 0 is undefined. So if I have 0 that's technically over 1, when I flip that, I get 1 over 0. Is that undefined? Yeah. Oh, I marked the wrong one here. That should be nice. Okay. All right. So now we're going to get to the graphing today. So now we're just going to be able to graph these and then move them. Okay, so inverse variation, that's what you guys just took your quiz on. That was k over x. Remember, x can't equal 0, so we just said it would be undefined. So what we are going to graph today, our parent function is going to be 1 over x. Okay, so this is what the curve looks like. Now, to make this, we're just going to make a table. Okay, and once we make our table, we'll graph a few points. Make sure in your table, though, that you notice we have negative numbers here, too. So we have negative numbers and positive because it's 2 branches almost. Okay? The other thing that's important today is, okay, the lines it passes. Just 1 second. Okay. Is asymptote. So you notice. Does it ever cross this line? No. Does it ever cross it? Those are called asymptotes. So I will be asking what those are. In this case, it's y equals 0. Here is x equals 0. You could say the x-axis and the y-axis, but it's actually going to be beneficial if we say x and y later. Okay? We just started on page 10. So that's what our picture is going to look like today. We're going to try one graphing. I put 2 tables on here to talk about the parent function and then how it changes. I'm not going to do that. All we're going to do is just make a table with these numbers. We'll talk about what that 4 does later. Okay? No graphic. Great. Have to do it by hand. All right, so here we go. Now, I have 4 on the top, so I want to pick nice numbers for x so I don't have a lot of fractions. Okay, so what would be a number I could use? Okay, so we could use, I'm going to go negative 4, negative 2, negative 1. I've heard 16, things like that. Hard to graph. Okay, so you want to pick numbers. Now remember, we need negatives, so that's why I chose those. Can I use 0? No, so we're never going to have 0. So now from here, I'm going to use the positives of this. So I'm going to have 1, 2, and 4. Now again, I should actually put, I'm going to put an 8 in here too. We are going to get a fraction and I'll show you why. Okay, but it's not a bad much. So I'm picking numbers that are goes in for it, these go into 4, however you want to do it. Okay, so let's look at the negative numbers first. If I put negative 4 in there, so 4 divided by negative 4, negative 1. Okay, so my order here then is negative 4, negative 1, so that gets me right here. Okay. If I put negative 2 in, divided by 2. Okay, so negative 2 gets me right here. If I put negative 1 in, what's 4 divided by negative 1? Negative 4. And you don't have to write it out, you can do it in your head. That's going to get me right down here. Remember, what shape does it make? The curve, right? When you draw this, if you cross the x-axis or cross the y-axis, I'm going to take a point off. Okay, just remember, it can't get 0. So it gets close, okay, but it's not going to get, it's not going to cross those lines. Okay? Now let's look at our positive branch. So here's our negative branch. Remember, we have 2. So now, notice we're going to get the same numbers, but what are they going to be? Positive. So I'm not going to write it out. But if we put 8 in, what's 4 divided by 8? That's a half. I'm going to do that because I just want to show you that it does get close to 0. Okay, so 4 gets me up here. 2 is here. 4 1's right here. And then 8 1/2 would be right there. So now I could do this one to a half. So there's my curve. Again, it will keep getting closer and closer to 0 as I keep increasing this. If I made it 64, if I made it 100, it's going to keep getting closer and closer to 0. And
you never touch it?
Never. Unless we move it. You know, but if it's just something over x, it'll never cross. So now we have to talk about domain. Not on reals anymore. Okay, a lot of the things we've studied before, the domain has been on real. But if I come in here from the left and I go to the right, what happens? Yeah, doesn't this purple one stop here and then my red one starts here? So what number do we say we can't have? 0. So what I do for domain is I just say x cannot equal 0. It's just a number that's not going to work. The one number I can't put into this equation is 0. Well then, as I come in this way, what number is not going to work? 0 again. Yep. So your range, remember, is y, so y cannot equal 0. Correct. It never touches them. Okay. That's how we do it. If it's something over x, then it would be true. Now, I want to look here. I do need to talk about asymptotes. I'm just trying to remember when I put it in my notes, so I'm going to look. Oh, it's on there. I just can't see it. Okay. So, if we look here, asymptotes. Okay, what that is, let's put a definition next to this. Asymptotes are the lines that the functions never cross. It's probably a formal definition of that word. Okay. It's any line where your function can't cross or touch. So if you notice here, this purple graph, see how it never ever, as I go to the left, it never crosses the x-axis, and I come in from this way, it's never going to cross the y. Because we did say x and y can't be 0, right? What's really nice, you know your domain and range, you know your asymptotes. Now, asymptotes are lines, so we need equations, right? Well, what's the equation of this for the y-axis? What's the equation? No, the asymptote here I'll highlight it. So the first one we're going to talk about is this one right here. That line right there is the asymptote. So what's the line? Yeah, so you could say the y-axis, but I don't want to. I want to use, what's the equation for this? X equals what? 0, isn't it? That's like our domain. Domain, you say it can equal the asymptote is the actual line. Okay, so for our asymptote, one of them is x equals 0. Now if I highlight the other one, what's that one going to be? Y equals 0. So asymptotes are lines. It's what your functions, they're not imaginary because they actually do this, but it's that line that these can't cross. They're barriers. Okay? It's related to your domain and range. If you know your domain and range, you know your asset range, or vice versa. Okay? Now, what do you think this 4 did compared to the parent function? Remember, the parent function is 1 over x. What's that 4 doing to it? Stretching it. It's changing our curve. Now, I'm going to go back a slide. See how our curve went through the point 1, 1 for the parent function? If we draw it, when it went to 4, didn't it go to the point 2, 2? It actually went, if we go at 1, it went up to 4. So it stretched it. So instead of being at 1, 1, it stretched it all the way up to 4. Okay? So same rules apply. If there's a number on the top that we're multiplying, that's a stretch or compress. And it says it's going to have a stretch. Okay? Let's try one more of these. 10 over x. You'll notice on this, and it's very, very hard to read, but these are going by 5s. I don't even know if you can read it on your light. Okay, but these we're going to say are going by 5s. Just each of the little lines are ones here. Yeah, well, it's like 5 here, then 10, and 20. Anyway. Yeah, that should be 15. It's hard to read. But that's what we're doing. Okay, so let's put our numbers in. What numbers do you want to use? What negative numbers?
5, 10.
Okay, so we'll go negative 10 on your first, negative 5, negative 2. That sound good? Okay, you could go negative 1. I don't know, we'll do an extra negative 1 and then we'll kind of see. Positive 1 there. 1, I'll go 5 and 10 just to separate it a little bit. Again, just picking numbers that are nice. I am going to, I'm going to sneak in a half down here just so we can talk about what to do. What if we do put a half in our fraction, okay? Into that. We'll talk about that in a second. Okay, so let's take the negative ones first. What are you going to get? Negative 1, 10 divided by negative 5. Divided by negative 2. Negative 5, and then negative 10, right? Okay, so let's plot those. So this we're going to say is 10 versus negative 1. And you just kind of guess on your graph. You know what to say. The ones on the homework are better. This is hard to read. Negative 2 gets me right here, negative 5, and then negative 1, negative 10. Yeah, what I like to do is almost highlight the line it's not going to cross. So we know it's not going to cross that y-axis, so I'm going to highlight that. I'm also going to highlight my x-axis. As a reminder, when I draw that curve, I can get close, but I can't go over it, okay? And then the blue one here, if I take 1, I'm going to get 10, 2, and 1. Okay, let's talk about a half. 10 divided by a half. How do you divide fractions? Multiply by the reciprocal. So what's 10 times 2? 20. So if I do a half here, so if I'm right here, I would go all the way up here to 20. So again, it's going to get close to that. So anyway, just so you saw that. So 1, 10 is about right there. 5, 2. So what's the domain? And can equal? Y cannot equal 0 for the range. Does it ever have any intercept?
No.
Yeah, I wrote down. So then asymptote, x equals 0 and y equals 0. You will have 2 because we have 2 branches. And it kind of goes around each of them. So you will have 2 lines there that are one cross. Okay? Okay, so now the last part here that I want to look at is, I'm going to actually jump ahead here just so we have time. Here's all of our transformations that we had before. Okay? If it's next to x, which way does it go? right or left, right? And then if it's on the outside, it's going to be up or down. So the same process that we have for our absolute values, for our parabolas, all that's going to be the same. The number on the top is A. Remember, we're going to use the word stretch. I use compress instead of shrink. You can use that for reflection instead of flip it. So instead of having our branches here, they'd be in 2 and 4 instead of 1 and 3. So all of those still exist. Okay. So let's try one. Okay. So let's talk about first, how is this going to move? So what's this going to do? Down 2. What's x plus 1 going to do? Left. And that's why, you guys, those transformations, I keep counting them on you when you guys come in, having you do that challenge, is because this is not going away. It's not going away next semester either. We have to know how things move. It's just a different function. So the first thing we have to do, remember, is plot the parent. Okay? I'm going to actually have multiple graphs on here, and then we can move it. So if we look here, so this is our parent one. So let's make a table for that. So let's pick. We'll go -2, -1, and then a half, -1/2. Let's pick those 3 for our negative ones. What? Yeah, so -2, -1, and then -1/2. If I put -2 in there, what do I get? 3 and -1/2. 1/2. If I put -1 in there, what's 1 divided by -1? -1. How about 1 divided by -1/2? 2. Put it in the calculator if you don't remember. Just take negative, or take 1 and divide it by 1/2, you'll get 2. So we're going to get -2 here. Okay, so I'm going to just put dots. I'm actually not going to draw the curve. But I'm going to go over 2, down 1/2, gets me right here. Okay, then to the left 1 and down 1 gets me right here. 1/2 and down 2 gets me right here. Okay, again, I'm not going to draw the curve because I really don't want to see a whole bunch of curves, but I need the dots on here. Now what we want to do is move those dots. Okay, so let's move those. So I'm going to go down 2 and left 1. So this one right here that is at 1/2, if I move it down 2, do you agree you're at -2.5? And then I have to go left 1, so it is now here. So this point, I don't want to draw arrows because it gets messy, but I moved it down 2 and over 1. The left 1. This one is a little bit easier. Down 2 and left 1 gets me right here. This half one, if I go down 2 and then over 1, I'm going to get right here. So now, and my curve. So you want to know those points to start with and then move them. So remember, when we had our absolute value, so I'm going to change this. So those ones that you've been doing for me earlier, remember, the parent starts at 0, 0, and then we have these points. Then you knew, okay, this is left and down, so I had to move this left and down too. So now I'm here, and then I drew my B. Okay, from there. Okay, so same idea. We got to take those points we know and then move them. Question? Now let's do the other half. Okay, so if I look at positive numbers, I'm going to use the same numbers. So I'm going to have 2, 1 and 1/2. Are my y's going to change? No, they're just going to be positive. Same numbers but positive. So I get 1/2, 1, and 2. All right, so 2 and 1/2 gets me right here. 1, 1 gets me right here, and 1/2, 2 gets me right here. So that's my curve before I move it. And you can pick any numbers you want, you guys. I'm just picking 3 that I think are easy to use. Okay, but you can pick any. Now these points, I have to move them. So let's move them. I'm going to do that in red again. So I need to go down 2 and then left 1, or left 1. So I'm going to get right here. This one, down 2, left 1, I'm here. Now what do I have? I have a y-intercept, don't I? Yeah. Okay. Then this one, I'm going to go down 2 and then left 1, so I'll be about right here. Then I get my curve. Now, what I almost would do your asymptotes first, and we'll talk about those, but I did want to show you the shifting, how that works. Okay? For my parent, do you agree your asymptotes are x equals 0, y equals 0? That's where we started, right? Well, if I had this line, but which way do I have to move it? Left. So now my asymptote, instead of being at 0, 0, is going to be at left 1. So you notice my red curve didn't ever cross that line. No. Okay. Now the other one used to be at 0, 0. How do I, or sorry, at y equals 0. Where do I move that one? Down 2, right? So now it is actually right here. So your asymptotes also move, because now we know it's, hey, we had y-intercept. So it's not y equals 0 anymore for that asymptote. It is now y equals -1. Okay, so a lot with this, we're going to practice a lot more today and then also next week. Okay, so here's your graph. So let's talk about the asymptote. You know what it is? They come from how you move it. I moved it 1 to the left, so instead of being at 0, it's left 1, so that's -1. So y equals -1, because again, that's what, not y, x. X equals -1, which is what I have here, and then y, if I go down 2, isn't that at -2? So y equals -2. Okay, so this was for the parent, but now I've moved it, and so these are my new asymptotes. Now, if those are my asymptotes, what's my domain? X does not equal what? -1. And the range then is not equal, not -1, -2, whatever the y value is. Okay, if I move down 2, not 1, that's what you're going to get. So what you might want to do is draw these asymptotes first, and that's what we'll do on the next one, and then draw your curve. You might find that easier. Okay? So personally, I think of what my parent one looks like, and then I move it. So instead of picking numbers to put in here to make my table, I actually just do the parent and move it. I do think that is easier, but again, you could make a table and pick numbers here, but you might get some different fractions. So. No. Then we'll have to deal with that, because then your table looks a little different. Yeah. Okay. I know it says you try. Let's do one more, okay? Because I do think it's kind of confusing. So what we're going to do is let's talk about the asymptotes first this time. So you can decide if you want to graph the curve or do the asymptotes. You can choose which you think is easier. Okay, so normally our asymptotes are at, let's do this one, at y equals, x equals 0, this one right here. Instead of x equals 0, how's this moving? To the right 4. So I'm going to write this, so this is going to the right. So once this line right here, have to also move right 4. So now what I'm going to do, and I'm going to write it, I'm going to put it in red this time instead of highlighting, it might be easier. So, and I always do dotted, you don't have to, you can do a solid, but this is my asymptote. So x equals 4, that's the line cannot touch. When I draw my curve, I don't want it to go past that.
Horizontal or vertical?
It's x equals 4, so it's going to be vertical. Okay. Now, if you look this way, this line, your horizontal line can move which way? Up and down. Do you agree? Because if I move it side to side, it gets longer, right? So here you're moving this up or down. So that was this one, and so this one is up 6. So now gonna move this up 6. So now my asymptote is up here. So it will now be able to cross the x and y axis. You'll be happy to know, do it in time. I'm not gonna ask you those. Okay. Because it is more work. Okay, so now we have our asymptotes. So our new asymptotes here, if we want to put them, are going to be x equals 4 and y equals 6. Do you agree this is all 6 for y? Okay. So now, you almost see this as our new quadrant, right? So now we're going to have the picture up here and a picture down here is what we're looking for. Because it used to be here and here, but it all shifted now a little bit up there. So we just kind of have moved our quadrant a little bit. Okay, so now let's talk about the parent function. I'm going to pick the same numbers. So -2, -1, half, negative half, sorry, positive half, 1 and 2. So I'm going to plot these and then shift them. We already know, and this is for 1 over x. Always for the parent. So I'm going to get a negative half, -1, -2, positive 2, positive 1 and a half. Your parent is just 1 over x. Yeah, so we're just going to plot that. So, and then what I'm going to do is then I'm going to shift them. So I'm going to put these in black and then I'll shift the other ones into blue or something. So that I have. Okay, so -2, -1 here. So here, oh, well, I'm going to draw it in. I wouldn't if I were you. I would not have it perfect, but I did. Here's my parent. Okay, now how do I shift it? What did we say? Yeah, so I'm going to take this point, I'm going to take the point -1, -1, that's the quickest one to do. I'm going to move that one right 4, 1, 2, 3, 4, and then up 6. 1, 2, 3, 4, 5, 6. Notice, wasn't this one spot away from my axis? That one's also 1 spot from the new one, okay? And then I would have a point here, and I have a point right here. So then, here's my new curve. That's the negative part of it. It's just shifted up. Now I do the positive one. So I'm going to go over a half, up 2, 1, 1, and then over 2 a half. So here, I'm going to draw it really small. So here's my parent. The black is my parent. And then I have to shift those. So if I take the point 1, 1, I'm going to go up 6. 1, 2, 3, 4, 5, 6. And then over 4. 1, 2, 3, 4. And I get right here. And then I'll be here. Here's my curve. So the blue one's my answer. So again, you don't have to draw the black one in if you don't want to. You can just shift it if you want. But that's what you're going to do. Questions?